All right, starting lesson 9.4, sums of powers of integers. All right, the sums of powers of integers, formulas here. Here we have I to the first power. All right, that's a fairly simple formula. We have I to the second power, and the formula gets a bit more complex, and they continue to get a bit more complex the higher in power you go. All right, but it's actually not that difficult. You have the formula here, you just plug in a value, and you have to be careful with your calculations. That's all. All right, so starting off with example 1, find the sum. I to the fourth power. So that means then that my n value is 8, and I'm using the fourth power formula. So I'm going to have 8 times 8 plus 1 times 2 times 8 plus 1 times 3 times 8 squared plus 3 times 8 minus 1 all over 30. And we get 8,772. For part B, notice that we have this difference here. I'm going to break it up into two parts. Okay, I have 5 and 1, and then I have 3i squared minus 5 here, and then I have I equals 1, and then I have 5i. All right, and I could take this constant here, and I could pull it out to the front. So I have 3 times 5 equals 1, I squared, and then minus sigma 5, and I could also pull out the 5 here to the front. So I got 5, and then I have I. Okay, so that simplifies things. Okay, now applying the formulas, I'm going to have 3, I'm going to use brackets here. All right, that's the 3 that I have in front here. I'm not doing anything with that. Now I apply the formula for I squared. My n is 5, so I have 5 times 5 plus 1 times 2 times 5 plus 1 all over 6. All right, there's my brackets, minus 5, not doing anything with this here. And then applying the formula for I to the first power, I have n, which is 5. Okay, so I have 5 times 5 plus 1 all over 2. All right, we simplify those. Just be careful with your calculations. I have 165 minus 75 equals 90. Done. Okay, it seems like there's a lot going on here. It's actually quite simple. Here we have a sequence of numbers. Okay, we're finding the first difference. That's what we have here. All right, and notice there's not a common difference, but if you take the difference of the first differences, then for the second differences, they're all the same. All right, now if that's the case, then you're working with a quadratic model. All right, if these are all the same, it's a linear model. If these are all the same, it's a quadratic model. Simple as that. All right, so it says if the first differences are all the same, the sequence has a linear model. That is, it is arithmetic. All right, now find the model for the sequence. Here's a sequence of numbers. Okay, so using this model here, all right, for the first term, that's equal to a, and then I have n, which is 1, because that's my n here, squared plus b times 1 plus c, and it's equal to the first term, which is 0. All right, then I have a sub 2 is equal to a times 2 squared plus b times 2 plus c is equal to 4. A times 3, or not, a sub 3 I should say, sorry, not a times 3. And then here I have a times 3 now, to the second power, plus b times 3 plus c equals 10. All right, simplifying all of these equations, I get a plus b plus c is equal to 0 for a plus 2b plus c is equal to 4. And then 9a plus 3b plus c is equal to 10. Okay, so I'm going to call these equations 1, 2, and 3. Alright, so I'm going to work with equations 1 and 2. For equation 1, I'm going to multiply it by negative 1. A plus b plus c equals 0 times negative 1. Second equation, not doing anything with that. Alright, so let me write the first equation down below that since it's been manipulated. Alright, and I cancel out the c's, and then I get 3a plus b is equal to 4. Alright, so now I have equations 2 and 3. And I get negative 1, and then I have 4a plus 2b plus c is equal to 4 times negative 1. I have 9a plus 3b plus c equals 10. Alright, so for equation 2, since I've manipulated it, here is the new form of equation 2. Alright, c's cancel out once again. So I have 5a plus b equals 6. Now I have these two equations here to work with. And I'm going to take the first equation, multiply it by negative 1. Oops, that's sloppy there. Alright, I have 5a plus b equals 6 on the bottom here. So I get negative 3a minus b equals negative 4, and then I have 5a plus b equals 6. Alright, then I have 2a is equal to 2. I divide by 2, and a is equal to 1. Alright, cool, I have a. Now I'm going to find b. I'm just going to plug a in here. And I get 5 times 1 plus b equals 6. 5 plus b equals 6. Subtract 5, and b is equal to 1. Okay, cool. So I'm going to take all these and plug it into the very first equation. So I get 1 plus c equals 0. So I end up with c equals negative 2. Alright, now I'm going to take all these values and I'm going to plug it back into the model. Alright, so now I have a sub n, which is equal to 1 times n squared plus bn, and that's going to be 1n, and then plus c, so it's plus negative 2. Alright, and simplifying all this, I get a sub n is equal to n squared plus n minus 2. Done. Alright, if you have any questions, please make sure to ask. Begin the assignment at the bottom of the page. We're done with the chapter now.